All right, welcome back. Again, I'm sorry this video is so long here. So what we just decided in the end of the last video was that in this example, our acceleration was 12 miles per hour per second. And what I think I did not stress enough because I was hurrying is the idea that the acceleration simply tells you how much the velocity changes every second. So if you look at this chart, it shows you every second the velocity goes up by 12. That's what the acceleration tells you. Okay, so I'm going to have you guys try an example on your own. Full screen this guy. Here we go. All right. So at this point, I'd like you to pause the video and try this. Okay, so I'm going to assume that you've now paused it. And here we go. Let's run through it. We're going to calculate the acceleration. So here's what we know. A large train is moving at 48 miles an hour when the conductor sees a cows on the track. He pulls the brake, and after 8 seconds, the train has stopped. So here's what we know. We know the train has an initial velocity of 48 miles per hour. We know that it has a final velocity of 0 because the train is stopping. Okay, and we know that that change takes 8 seconds. So to find the acceleration, it's Vf minus Vi all over t. Our final velocity was 0. Initial velocity is 48 miles per hour. Time is 8 seconds. 0 minus 48 gives you negative 48. Divided by 8 gives you negative 6 miles per hour per second. Okay, so what that's telling us is that the train's velocity decreases, right, because it's going from 48 down to 0, by 6 miles per hour every second. Okay, and what does it mean that the acceleration is negative? It means that the velocity decreases, right? I want to make sure you guys understand this idea that this decreases comes from the negative sign. Okay, so there we go. So the only problem with this example and the previous example is these stupid miles per hour here. And we, being scientists and sciencey, don't want to use miles per hour. We need to use the metric system. So we're going to do another example here where we use meters per second. So prepare yourself. There we go. Oh no, I'm sorry, I forgot. We need to fill in the chart. So in that last example, I have already forgotten. What did the velocity begin at? 48, right? So the velocity began at 48 miles per hour. And then our acceleration was negative 6. So every second, the velocity is going to decrease by 6. So every second, the velocity decreases by 6 miles per hour. So here we go. 42, 36, minus 6 would be 30, minus 6 is 24, minus 6 is 18, minus 6 is 12, minus 6 is 6, minus 6 is 0 because the train has stopped. Unfortunately, the cow is saved. All right, and then on this one, we can fill in the speedometer. So the velocity started at 48, and then every second it goes down by 6. So 48, 42, 36, 30, 24, 18, 12, 6, and 0. Oops, try that again. 0. Yeah, it's not going to let me. That's 0. Okay, so moving on. So here we're going to do basically the same thing. Again, the answer is already showing. I'm sorry, I need to tweak this presentation here. But anyway, so hopefully you've got a good understanding of what acceleration is. Again, the problem is we can't measure acceleration in these units, because it's not metric. So we're going to, from now on, measure our velocity in meters per second, which is cool because it's metric. The only problem is most students don't know what a meter per second is. So just for your own frame of reference, you should know that 1 meter per second is about the same as 2.25 miles per hour. Okay, when I'm doing the calculations in my head, I usually just double it. So if the problem says you're going 30 meters per second, in my head I go, oh, that's a little more than 60 miles an hour. Okay, so we're going to do almost the exact same example. All right, so here we go. A car is driving at 23 meters a second, which for your own reference is a little more than 46 miles an hour. So a car is driving at 23 meters a second when the driver hits the brakes. After 4 seconds, the car is only going 11 meters a second. So we're going to find the acceleration. All right, so let's do this. Given, here's what we know. We know the initial velocity was 23 meters a second, because when the car first started moving, that's how fast it was going. Oops. Yeah. We know the final velocity is 11 meters per second, because that's what the car is going to slow down to, right? We know that the time is 4 seconds, because that's how long it took to slow down, and we're trying to find the acceleration. Not sure what happened here, why this didn't line up. All right, so anyway, we're trying to find the acceleration, so we're going to go through the same process we did before. Here's our equation for acceleration. I'm going to plug in my numbers. My VF is 11 meters a second, minus my initial was 23 meters a second. Takes 4 seconds. Do your subtraction. 11 minus 23 gives you negative 12. So this is telling me that the velocity is going to decrease by 12 meters a second in 4 seconds, which means the velocity is decreasing by 3 meters per second every second. So here is our answer. I will explain this in 1 second. Okay? So the idea is, in our last example, we had an acceleration of -6 miles per hour per second. So I was telling you how much the velocity decreased per second. Okay, now we're doing the same thing. We've just got different units. Instead of measuring our velocity in miles per hour, we're going to do it in meters per second. Okay, so now we've got -3 meters per second. So now I'm telling you that every second, the velocity decreases by 3 meters per second. Okay? Now, it turns out that you can go through some algebra. I'm not going to bore you with it on the video right now. If you want to ask me in class, I'm happy to show you. It turns out you can simplify this, meters per second, because that sounds weird, right? Meters per second. You can simplify it like this, -3 meters per second squared. Okay? So let me scroll down so you can see all of this a little bit better. All right, so here's what we just decided. We decided that our acceleration is -3 meters per second, or -3 meters per second squared. And here's what it means. It means every second, the velocity decreases by 3 meters per second. Or over here, unfortunately, we got to do this. Every second, oh shoot, I switched colors. Abort. Let's try that again. Okay, so here we go. Every second, the velocity decreases by 3 meters per second. Sorry, I get an F for that. All right, so in the last problem, our velocity was decreasing by some number of miles per hour. Now it's decreasing by some number of meters per second. Wow. Shoot, I did not make a chart. So what that means is this. If you were to make a chart, it would look like this. Time in seconds, velocity in meters per second. So at time 0, when we first saw the car, it was moving at 23 meters a second, right? And this is telling me that it's going to decrease by 3 every second, right? So after 1 second, the velocity is going to be 20. After 2 seconds, it's going to be 17. After 3 seconds, it'll be 14. And after 4 seconds, it'll be 11 meters per second. So every second, the velocity decreases by 3. All right. So here's one last example. This time, I am going to give you the acceleration. So in all of the problems we've done so far, we've been finding the acceleration. This time, I'm going to give you the acceleration. All right, and this one, I think the things actually click in the right order. So here's what we've got. We've got a car is driving at 27 meters a second when the driver hits the brakes, causing the car to accelerate at -4 meters a second squared. Notice, because the units are meters per second squared, I know that has to be the acceleration just by looking at the units, meters per second squared. Okay? So what we're going to try to do is we're going to try to find the velocity after 6 seconds. Okay? So let's do this. I believe this is our last example. So here's what we know. The initial velocity is 27 meters a second, right? The velocity begins at the velocity begins at 27 meters a second, so that's what goes here, right? So that is this. All right? We know the time is 6 seconds, right? We know the time is 6 seconds because that is, whoa, that was weird. We know the time is 6 seconds because that's what the problem told us in the original problem, right? So that is why over here we've got our 6 seconds. Sorry, why over here we have 6 seconds on the chart, right? Okay, so we also know the acceleration. It's -4 meters per second squared, right? Which means this. It means every second the velocity decreases by 4 meters per second. That's what the acceleration tells us. The acceleration tells us this information here. Every second the velocity decreases by 4. So look what I did. I just kept subtracting 4. We started at 27, minus 4 gives you 23, minus 4 gives 19, minus 4, minus 4, minus 4, until you get to your final velocity of 3 meters per second. Okay? So I believe I shouldn't speak yet. Let's see. Oh, all right. So eventually we're going to learn how to do the second solution using algebra. For now, I'm not going to worry about that solution. All right. This first assignment, we're really just going to focus on these charts here. Because the charts show me that you understand the concept of what acceleration means. All right. I'm going to leave you with this one last thought. This statement right here is of ginormous importance. Your acceleration tells you what the velocity does every second. All right. Again, I'm sorry this video is so long. This is the last one that'll be this long. The next 3 videos, 2 or 3 videos will all be well under 15 minutes. All right. So I hope you've enjoyed your physics outside of physics. Tomorrow, awesome things will happen.